What up, mathletes? Whoop, whoop. All right, let's do this. This is 6.1, one-step inequalities. And your learning target today is I will solve inequalities by using plus, minus, times, and division. All right, this is your warm-up. Take a minute, and I want you to solve each of these. Ready, set, go. All right, I'm assuming you pause this, so let's go ahead and do it. We're just going to get right into it. Negative 54 minus 54. And if I get that negative p equals negative 34, then I know that positive p equals positive 34. Boom. Minus 5, h equals negative 12. Divide by negative 3, divide by negative 3. Then I get that t equals negative, because a positive divided by negative is negative 68. Don't forget the triangle if you ever miss it. Negative, negative, positive, right? This was a positive divided by a negative is a negative. Right? Just little tricks you can do. Multiply both sides by the reciprocal, which is 3 halves. Put 60 over 1. And guys, start getting used to this cross cancel. 2 goes into 2 once, goes into 60 30 times, cuts it in half, right? 30 times 3 is 90, so J, by the way, these canceled out. J equals 90. Boosh, right there. Okay, we're going to write some vocab. I'm going to throw it up. I've actually written it using nice handwriting. Thank you very much. Okay, an inequality is a mathematical sentence that contains the symbol less than, greater than, less than or equal to, greater than or equal to, or does not equal. Mathematical set builder notation is a mathematical notation that describes a set by stating the properties that its members must satisfy. We'll talk about set builder notation a little bit today. All right, go ahead and pause this. We're going to move on. Ready, set, go. Okay. Move this up so you can see it. Right. And I want to talk about the different meanings of all this. So we have less than or equal to. So less than looks like that. Okay? And if I were graphing it, it would be an open dot that goes to the left. If I have less than or equal to, it just adds that little extra. So it's like an equal sign combined with a less than sign. And it would be a closed dot going to the left. The difference between these two dots is this one says, hey, everything up to this point, but don't include it. It's like parking a car. Everything up to this car, but don't hit it. This one's saying, go ahead and hit the car. I include this point, right? Greater than is this way, and it would be an open dot and graph to the right. Greater than or equal to is a closed dot, or I'm sorry, greater than or equal to sign with a closed dot and to the right as well. Okay, one of the ways we would say less than, 5 is less than 6. That's true. 3 is less than or equal to 3.5. That is also true. 1/2 is greater than 1/3. Boom. 4 is greater than or equal to 4. That is also true because 4 equals 4. So lots of different examples here. Now I'm going to show you how to graph. A lot of these, they'll put these big number lines on there. Really, I want to teach you that in most of these problems, we only care about 1 at most 2 points, okay? So it says graph the following. Here's what I'm going to do. N is greater than 0. So I'm going to write down 0. It's the only number that really matters for us. And we see right here, that should be an open dot. And we graph everything to the right. And we know that's true because like 1 is greater than 0, 2 is greater than 0, 3 is greater than 0. You'll see some people that just darken in the thing to the right. And that's fine. I like to do the one that goes up and to the right. P is less than or equal to 2. All right, less than or equal to is a closed dot. The only point we care about is 2. And to the left is less than. Take a minute, see if you can grasp these two. Ready, set, go. Okay, I'm assuming you paused it if needed. All right, point we care about is negative 3. Greater than or equal to is a closed dot and everything to the right. Less than, the only point we care about is 4. It's going to be an open dot to the left. Okay? Now, we're going to go the other direction. This was taking an inequality and writing the graph. Now we're going to take the graph and write the inequality. Well, notice right here, we have an open dot, and it's everything to the right. Which one has an open dot and everything to the right? That's greater than. So we're going to have x is greater than, and what's the number we're on? -8. Boom. See how that worked? This is a closed dot and everything to the left. What is a closed dot to the left? That's less than or equal to. So we know this is less than or equal to. We're going to have x is less than or equal to what? What number are we on? 3. Take a minute and see if you can do these two. Ready, set, go. Take my coffee sip, right? It's my moment. Okay, I'm assuming you graphed this or already did this. So again, this is a closed dot and everything to the right. Let's match it up here. Closed dot to the right is greater than or equal to. So we're going to have our greater than or equal to sign, and x is greater than or equal to what number? -50. Over here is an open dot and everything to the right. That's just greater than. So we're going to have x is greater than what? 1.4. Boom. Now I want to talk to you about the differences of solving an inequality with solving an equation, okay? So if I were to solve this equation right here, x minus 10 is just going to be plus 10 plus 10. I get x equals 25. So this gives me a specific number that x equals. Inequalities give us a solution region. Okay? So let's look at this one right here. X minus 10 is less than 15. Same question, but I've changed the equals with a less than, so this would be plus 10 plus 10. So our answer is x is less than 25. And to graph that, so where we have only one answer here, the difference is this, it's less than, so it's an open dot, it's everything to the left. Any value of x that is less than 25, 24, 23, 22, -5, -1.5, any answer that is less than 25 would make this true. All right, x plus 24 equals 15. So I'm going to subtract 24 from both sides. I get x equals, what is that? We know it's going to be negative, so let's just do 24 minus 15, which is 9. X equals 9, again, a single answer. Okay, guys, full disclosure, this is supposed to be 15. I think I was falling asleep as I was writing it, so let's just replace it. So now we have x plus 24 is greater than or equal to 15. Same question, just transposed, greater than or equal to for an equal sign. Same process, minus 24, minus 24. I'm going to have x is greater than or equal to -9. So this solution region, we look at -9, closed dot, everything to the right. Okay? There is going to be a difference. So notice, we solved these the same way. It didn't change anything. There will be one situation that does change everything. Pauses is needed. Let's move on. Okay, so now we're going to solve inequalities with variables on each side. So now just know I have an a on the left and the right, a y on the left and right, g, oh, this one doesn't have variables on both sides, neither does this one. But we'll talk about these anyway. These are different. Okay, are you ready? So to solve this one, what am I going to do? Well, I got choices. I'm just going to subtract a minus a. And I get that -5 is less than a. Now I'm going to flip this around. Notice the big end is pointed at the a. So if I want to write a on the left, I have to have the big end pointing at it and then -5. And it's just a is greater than -5. Super easy. So that would be -5, open dot, and graph to the right. Let's try this one. Same deal. 9y. I'm going to subtract 9y because I want to keep it positive. And I get 3 is greater than or equal to y. Now, again, the little end is pointed at the y, so I'm going to put y on the left and go less than or equal to 3, which is just a graph of 3, close dot, and everything to the left. This one right here, the only difference here is this has decimals. So minus 3.7. Just remember we can put a 0.0 here. Minus 3.7. We're going to have to borrow, make that 4 and that a 10. That's gone. I get G is less than or equal to, let's see, 10 minus 7 is 3. 4 minus 3 is 1. 1.3. Perfect. So then I'm just going to have 1.3, close dot, everything to the left. My last one over here is a little different. I kind of want to show you how to solve this. I'm going to show you, well, I'm going to do it this way. I'm going to go ahead and add n to both sides, and I'm going to subtract 1,000 from both sides. That's the easiest way, I think, to do it right now. There's a reason why I'm doing this, and I'll show you later. So this is going to be negative 680. That's gone. Is greater than. That's gone. N. And again, little n, little side point at the end, so we're going to have n is less than negative 680. Just a graph at negative 680. Open dot, everything to the left. Okay. We'll come back to this in a minute. Okay, are you ready? All right. Uh-oh, multiplication, division, and negatives. Oh my. Well, let's do it. Same thing. Divide by 2. Divide by 2 doesn't change anything. X is greater than 6. 6, open dot, everything to the right. We still got to multiply by reciprocal. 5 halves. So crosses out. 5 halves over 1. We're going to have x is less than or equal to. 2 goes into 2 once, goes into 8 4 times. 4 multiply across. 4 times 5 is 20. 1 times 1 is 1, and that's just x is less than or equal to 20. Boom. The only point we care about is 20. Close dot, everything to the left. Now, I'm going to solve this one 2 different ways because I want to show you what's going on here. I'm going to add 3x to both sides. Add 3x. And add 9 to both sides. Add 9. So I'm going to have 9 is greater than or equal to positive 3x. Divide both sides by 3. And we get 3 is greater than or equal to 3x, or than x, excuse me. Which little n's point at the x, so this would be x is less than or equal to 3. I want you to keep that in mind because I'm going to solve this a different way now. Okay, just watch. This is the one situation when you have to multiply or divide by a negative, things change. Because watch how, because you're probably thinking, why didn't I just divide by negative 3? Well, watch this. Negative 3x is greater than or equal to negative 9. Let's divide by negative 3. I'm going to ignore this inequality for a second. That's gone. I get x. Negative divided by negative is a positive 3. Notice if I just write this straight down, it's going to be x is greater than or equal to negative 3. But I just proved to you that it should be less than or equal to negative 3. That's because when using inequalities, the one difference from an equal sign is that whenever you multiply or divide by a negative, you must flip the sign. So when you multiply or divide by a negative, flip the sign. Okay? That's the one big difference. So when you multiply or divide by a negative, oh, hi, I had it written right here. Flip the sign. Okay? So let's do this last one. I'm just going to undo division. I'm going to multiply everything by negative 5. Negative 5. That means this crosses out. I'm left with x. I'm going to flip the sign is greater than. Negative 5 times 3 is negative 15. And I'm going to have negative 15. Open dot to the right. With that said, you got this. Peace out.